So a final related rates problem, just for good measure, says the volume of a sphere of radius r is changing. At what rate is the radius changing? So let's annotate that. We're looking for dr dt. What rate is the radius changing if the volume increases at 10 inches cubed per minute? So the volume increases. They're giving us another rate. So the volume is increasing. That means that the rate is positive. 10 inches cubed per minute. Oh, and the radius is 5 inches. So notice they didn't say the radius is changing at 5 inches, just the radius is 5 inches. So this is all our information. Remember our 3 steps from before. Is to draw a figure. For this one, I mean, we have the formula, we already have the relationship, so we don't need to draw a figure. We'll just use this relationship right away and jump into step 2. And so let's copy it down. And then take the derivative on the left and on the right. So I'll indicate that using d dt to remind myself that I'm taking the derivative with respect to t. So to see if you can do it on your own. The derivative of the volume is, with respect to time, dv dt. Now on the right side, careful, 4/3 pi, all of that together is just the constant in front. So we always just copy that down. So it'll be 4/3 pi, gets copied. Now the derivative of r cubed, so is r a constant or is it changing? Well, they told us the radius is changing. So, so we'll have to take the derivative. So it'll be r cubed, the derivative is 3r squared times dr dt. Great, let's see what we're solving for. We need to find the rate at which, we need to find the dr dt based on the question. At what rate is the radius changing? So we need to know everything else. Do we know dv dt? Check, it's right here. Do we know r? Check, it is right here. Do we know pi? Just kidding, that's a constant. So we're good to go. Let's plug in everything and then be done. 10 equals 4/3 pi times 3. By the way, don't these 3's cancel? So let's take care of that. And then r is 5, and so 5 squared gives me 25, and then dr dt. Let's simplify. I have 10 equals 4 times 25 is 100 pi dr dt. And now I'll solve for dr dt by dividing both sides by 100 pi. Our final answer then is dr dt equals 1/10 pi. And our units, well, let's see what units they used in the problem. The volume is increasing at, the units are inches cubed per minute. So that means our radius would be changing at 1/10 pi inches per minute, because radius is measured in inches. I should have actually labeled that right here. And we're done. Hopefully that one was straightforward and you could have done it yourself.